Assalamualaikum. My name is Mursyidi bin Anuar from BEI, Faculty of Electrical and Electronic Engineering Technology. My matric number B0818100887. My supervisor technologist Asri bin Din. Today I'm going to present my bachelor degree project, which is classification of surface degradation based on leakage current energy of 6-year field age polymer insulator using support vector machine. Okay, for the project description, the main aim for this project is to propose a systematic and effective methodology to estimate the classification, surface degradation of leakage current energy on 6-year field age polymer insulator. Okay, for introduction, insulator is used an electrical system to prevent unwanted flow of current to the earth. From its supporting point, it is a very high resistive path through practically no current can flow. In transmission and distribution system, the overhead conductor are generally supported by supporting tower or pole. The towers and pole both are properly grounded, so there must be has an insulator between tower or pole body and the current carrying conductor to prevent the flow of current from conductor to earth through the grounded supporting towers or poles. In this project, polymer insulator that 6-year field age has been used to determine or to classification surface degradation using support vector machine. Polymer insulator generally has two parts, which is glass fiber reinforced by epoxy resin rod-shaped core and weather shade that made by the silicone rubber. Weather shade function is as a protection for the inner part of the insulator, which is insulate core from the outside of the environment. Polymer insulator also called as a composite insulator, which was designed to install in overhead power line, and it is also resistive from UV radiation, weathering, aging impact, and chemical influence. Okay, for the problem statement for this project, polymer insulator are material that will slowly facing degradation if it exposed to environment for a long time. Pollution and environment are factors that will increase the degradation for the insulator. There have been several studies on the impact of weather, pollution, and mechanical on polymer insulator, but there are no considerable study in the literature for polymer insulator issue caused by age, surface roughness, and insulator degradation. Therefore, the problem statement for this project is polymer insulator are material that will slowly facing degradation if it exposed to environment for a long time. Pollution and environment are factors that will increase the degradation for the insulator. There have been several studies on the impact of weather, pollution, and mechanical on polymer insulator, but there are no considerable study in the literature for polymer insulator issue caused by age, surface roughness, and insulator degradation. Okay, for objective for this project is to investigate the surface of polymer insulator level of degradation that have been exposed to the environment in 6 years at field age. To experiment the ready data of leakage current of 6-year field age polymer insulator using machine learning test support vector machine (SVM). Okay, to get the experiment result classification, the surface degradation by using IEC TS 62073 edition 2.0 and comparing the criteria of hydrophobicity class. Okay, for research methodology, MATLAB is a high-performance programming language for scientific and engineering application. In MATLAB, we are using simple coding of support vector machine to convert raw data from LVM to MAT, and also make a classifier for ready data leakage current energy using the software. Okay, this is my project flowchart. Flowchart can help organize through and layout the needed data gathering. First is data collection. Data collection consists ready data, leakage current that have been collected from IPT test, surface roughness test, and hydrophobicity test. So the ready data leakage current was from LVM format. So we have to convert LVM format to MAT file format. After that, we got to process leakage current data using spectro. From there, we will get a leakage current energy. If it's sufficient data, it will go back to the process SVM. If it's not sufficient, it will go back to the ready data leakage current. The sufficient data will be processed through support vector machine to be classified, so that the data will be analyzed. From that analyzed data, we will see if the data will be differentiated or not. If the answer is yes, the data will be able to determine the consistency performance measure to indicate the class of insulator surface degradation. If the analyzed data cannot differentiate, it will be sent back to the process leakage current data using spectral. Okay, for the surface roughness. Okay, from this plotted graph for arithmetical mean surface roughness, the value of arithmetical mean surface roughness for sample 12/20, which is control sample, is the most lower than the other sample, which is mean that this sample has a most clean surface area. The characteristic for control sample to be chosen, has a least surface degradation occur and clean compared to the others. Okay, the control sample that have been chosen will be cleaned more with alcohol, and then that's the reason is to make it easily to compare the surface roughness between control sample and unlabeled sample. So from this plotted graph, we can see that the difference between control sample and unlabeled sample based on the surface roughness. For example, as you can see, unlabeled sample 16/20 is the lowest sample polymer. It's the lowest unlabeled sample polymer that facing a surface degradation than any sample, and the highest most arithmetical surface roughness value is unlabeled sample 19/20. The different value of arithmetical mean surface roughness can shown which is sample that has more total harmonic distortion. When the value of total harmonic distortion occur, it can cause a discharge on the surface of polymer. The more discharge occur, the more degradation happen, and it will decrease the hydrophobicity on the surface of the polymer. Okay, for the hydrophobicity contact angle, the lightning arrestor housing had a hydrophobicity type of surface, and this insulator is extremely important for keeping the lightning arrestor secure and stable when it comes to preventing high voltage from passing through. So when the insulator ages, the originally hydrophobicity surface of the shape become hydrophilic, allowing a water layer to form easily in a humid environment, resulting in a current leakage. So based on hydrophobicity contact angle plotting graph, the list of the value of contact angle of the hydrophobicity, the more degraded process can happen on the surface of the insulator. So to analyze the leakage current, the sample that have less contact angle are the selected characteristic. It is because sample that has a least contact angle between the two locations has a high possibility of formation water droplet on surface polymer insulator. For percentage of accuracy, classification accuracy. Okay, the study of leakage current energy for 6-year field edge polymer insulator required three important parameter, which is total harmonic distortion, total non-harmonic distortion, and energy. Okay, furthermore, for one sample has a 16 data that need to convert to LVM to MLT. Okay, overall there are 11 sample including control sample. Each sample will be chosen one data. The characteristic that data will be chosen must have the highest value of the THD among the other data. It is because the THD value show that the leakage current happen on the sample. So to achieve the objective for this study, the high value of the THD required in this classification of leakage current. This graph shows that the percentage of classification accuracy for each parameter between unlabeled sample and control sample. In this part, control sample will be compared by the unlabeled sample data to determine the percentage accuracy. This process can show whether the sample is still in good condition or bad condition by calculate their percentage of classification accuracy. Percentage classification accuracy is the calculation simple machine learning in the support vector machine that using a coefficient method to be classified between two samples. If the percentage classification accuracy reach 100% below or near to 100%, that means the difference between the both sample is large, and if the percentage reach 50% below or near to 50%, that means the difference between the two samples is small. For example, MLT1, okay, if the reading percentage THD for MLT1 is 51.66%, and for the percentage THD is 61.66, and the lastly for energy is 58.33. Okay, based on this data, we can conclude that the percentage classification accuracy for the three parameter is near than 50%. So that the data for both label sample 2/20 and control sample is nearly similar, which is mean label sample 20/20 is in a good condition. Okay, for the relationship hydro and hydrophobicity and classification accuracy. Okay, the classification of hydrophobicity class for each sample is determined according to the angle of contact for each sample and refer to the standard IECTS 62073 guideline. Therefore, all the contact angle for each sample is shown that all of them in hydrophobicity class 1, which is you can see on this table. Okay, that means the layer of the hydrophobicity surface polymer is still in good condition. Based on this table, we can see that all sample from hydrophobicity class 1 have their contact angle above than 60 degrees. That make the layer of hydrophobicity on surface of running arrestor still in good condition. The percentage of classification accuracy also in range of 50%, which is the data is the same to control the sample except for 6/6 S6 and S10. Both of this value percentage range is far more than 50%. So, based on these two value of percentage from sample S6 and S10, the observation can be made when the value of percent CA for energy increase. The percent CA followed by the TNHD value, even though the value of percent energy will remain in range 50%. This observation based on this table, the existence the TNHD can make the value of percent CA energy increase and can cause the value of the leakage current energy increase a little bit. Therefore, the good hydrophobicity of polymer insulator leads to good surface condition, which is mean that the degradation of the surface is barely happen. Therefore, the value of leakage current energy can also affected by hydrophobicity, because high hydrophobicity cause the THD to become zero and discharge on the polymer surface to be prevented. The value of arithmetic mean leakage current energy can still occur. However, the value still in the small amount. Okay, for the project feature, the sample shown that the 3 sample from the lightning arrestor that exposed to the environment for 6 years. Sample A is a control sample and the sample B is a sample 16/20, and lastly sample C from the sample 20/20. This figure shows that the visual observation of 6-year polymer insulator, and the observation is the different condition for the surface insulator between 3 sample. For the sample 12/20, which is control sample, has a list of no degradation occur on the surface of polymer compared to the unlabeled sample 16/20. It is caused by the surrounding environment and the polluted weather for 6 year, which is lead to surface degradation and affect the polymer to loss of gloss and surface roughness. And for the lastly, for the conclusion, although from hydrophobicity class of physical evaluation such as surface roughness and contact angle, all the samples are still in the hydrophobicity class 1, but the result we get from looking at the existence of energy content in the leakage current show that there is a potential for us to see the difference in degradation occur even if it in a small value. Okay, that's all from me. Thank you.
Assalamualaikum. This is a simulation for this project. Okay, first this is a raw data. Okay, the raw data in LVM format, so we need to convert to MAT format. Okay, first we need to open MATLAB, and after that we need to import data. Import the raw data. Okay, open. Okay, we need to choose this sample only. Okay, after that it appear here, so we need to rename first. Okay, rename Y006 mean from 6-year field polymer insulator, and 02 for sample 2/20, and 01 for the first minute number 1. Okay, after that we need to save as this file into the file that have been converted. Okay, here. Okay. Okay. Okay, after that we need to open. We need to call it that. Okay. Okay, and then all the MAT ready data that have been converted appear here. Okay, after that we need to open the spectral diagram to exact the data from the raw data. Okay, this is spectral, but first thing is we need to run this first. Okay, we need to run first. Hit pass. Okay, after that we need to run the spectral. Okay, for the exact of the data, first we need to change a little bit coding, and this coding 02. Okay, and here. Okay, as you can see here is 106000. So if 1600, we need to the answer is the value is 53. So we need to change here for 53. Okay, after that we need to run. Okay, after you run, okay, we need to put we need to display, we need to calculate the value of THD, TNHD, TWD and IRMS. Okay, just copy here. Okay, this is the value of THD, TNHD, TWD, IRMS. Okay, okay, for me, my study is to find the leakage current energy. So I need to run one coding, which is feature. Okay, okay, run feature and copy min. Min 2 is min for 2-dimensional min. Okay, this is the value of the energy. Okay, after that we got a THD, TNHD, TWD, IRMS and min 2, 2-dimensional min. So we need to update this here based on the sample. Okay, this is the simulation for SBM. Okay, first we need to run this program. Okay, and enter run. Okay, so this is SBM coding. Okay, first we need to import. We need to import Excel like here. Okay, okay, we need to pick this for energy for sample number 1. And after that we import energy, TWD, TNHD, THD and label for the classification. Okay, so okay, here all of them that have been imported. Okay, first we need to drag label and then the first parameter THD. Okay, and after that we need to change the coding a little bit. Label, which means here, and THD. Okay, after that we need to run. Okay, you show here the classification accuracy is 51, which means the data is same to the control sample. That means the degradation equal to the compared to the control sample. Okay. Okay, here is the data that we need to collect. Okay, fall. We copy here and we paste here. Yes, like this. For each sample, we need to do the simulation. Okay, after THD, we need to put here for TNHD. Okay, level 1, okay. And then we run. And here shown the accuracy 64. Okay, for the energy. Take all the reading and put it here for classification and analysis.